Okay, I had a family member call me and say that their upstairs AC unit was not working. Told them I'd help them out. When I got there, I noticed the thermostat had dead batteries. I replaced the batteries, set the thermostat to cooling, went outside and made sure the condenser was working and turning on. The condenser had turned on and was running, but I still had no airflow blowing upstairs. So what I'm doing now is I'm climbing upstairs into the attic, and I'm gonna get this cover off and inspect the upstairs air handler. Anything that I do will be done in good faith. It'll be done correctly. I'm not gonna cut no corners. I'm not gonna do anything unsafe. And if I can repair it, I'll tell you. And if I cannot, I'll be 100% honest with you and let you know. Say, look, man, this is out of my scope. This is out of my wheelhouse. But I will get you in the right direction, so you can have a good conversation with the AC company, and you can be informed and you can know what's going on, because that's what a lot of this is about. So what I'm doing right now is I've got the electrical cover off of the attic air handler. Now this is a two-story home with two air conditioning systems. One cools the downstairs and one cools upstairs. This is the upstairs air handler inside of the second-story attic. So what I'm doing is I got the cover off and I'm just doing a real good thorough scope of the lay of the land. I'm smelling for anything that might be burnt. I'm looking to make sure I don't see anything that's burnt or hot spots or anything that might be broken. You always want to get a good scope of the land before you start sticking your fingers in there, sticking your tools in there and moving things around. You want to get a condition of how things are currently with the system not working and the system out of service. That way you don't get yourself further into a problem that you won't be able to get yourself out of. Right here I'm discharging this capacitor, and I'm going to take the capacitor off and test the capacitor. Okay, what I'm doing right here is I'm discharging the capacitor. These capacitors are basically like an AC voltage battery. They store a lot of potential voltage. So anytime you work on a capacitor, you want to discharge it. 5 microfarad. Bad capacitor. See that 1.8 microfarad? This is a 5.0 microfarad. So this capacitor is definitely bad. You see a little bit of disformation bubbling up. So we'll read this again. So basically, take your multimeter. If you have microfarad abilities on your multimeter, which this multimeter does, we're going to switch it to the ohm reading, which is continuity, basic continuity. But then we're going to press the yellow function button because we want this yellow symbol, which is a symbol for reading capacitance, microfarad. So we're going to press the yellow function button and we're going to see our symbol here change. Right now this is on ohms. That's the ohm symbol, which is the indicator that we are reading ohms. We are reading continuity. So we're going to change our function. This will tell us which function we're going to be in. Microfarad. That's this yellow one right here. So see that it's open line because I'm not reading through any capacitor cells. So this is a 5 microfarad capacitor. We're going to read across the two terminals. 1.82 microfarad. That's terrible. It's terrible. So I'm gonna go see if I can find a good capacitor. I think the homeowner has one. Let me take all my stuff, because I may need to do some testing. And this is always the most difficult and funnest part, climbing in and out of an attic, because you definitely do not want to fall through a person's attic. So again, we're going to continuity setting, but we want the secondary function, which is capacitance. So we're going to press our function button, and you're going to see right here, this function is going to change from continuity to capacitance. So now we're going to take, this should be a 5 microfarad capacitor, and you can see it has a 5% tolerance. So I should read 5 microfarads, give or take 5% of that. So what do I have here? 4.5. And is it open to ground? I'll check continuity. I'll check to ground, because you don't want this thing shorted out. Open to ground on this terminal, open to ground on this terminal. Okay, now I'm pretty confident that this capacitor is going to fix our problem. Let's go ahead and get back up inside the attic, make sure we don't stick a leg or a foot through the sheetrock. We're going to be extra careful, and we're going to get about the business of installing this capacitor. And I was very fortunate that the homeowner actually had a spare capacitor. It was a used one, but it was spare and it was still reading good. You know, we were still in a usable reading for this capacitor. Now, one thing I do need to check is the condition of this blower fan. I'm going to ohm out these motor leads and see what the windings are. 42 to ground, open, open, 42. I mean, that kind of tells me that the blower is good.